Welcome, everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to use the SSS theorem and SAS theorem to prove that true triangles are congruent. How are we learning it? Through the SSS and SAS Congruence notes and the SSS and SAS Congruence assignment. When can we use this information? To group items together based on limited but similar information. How do we know we learned it? By getting a score of 4 on SSS and SAS Congruence assignment. Now let's take a look at our agenda for today. We will begin by going over the learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. After that, we'll go over the SSS and SAS Congruence notes, and then I'll give you time to complete the SSS and SAS Congruence assignment on Desmos. Once you've completed the assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your Before You Go. Your only homework for tonight is to continue working on the Triangle Congruence Study Guide and any incomplete assignments that you may have. Let's take a look now at the SSS and SAS Congruence notes. The notes begin with the learning goals and success criteria. Now, understanding congruence. In order to show that two triangles are congruent, we must show that all the sides and all the angles are congruent. So first we need to state the parts that are congruent. Well, we have AB here with a single dash, and we have DE here with a single dash, so those are congruent. Now notice, I said AB is congruent to DE. I didn't say AB is congruent to ED, because that is not a true statement. In order to make a true statement, I need to follow along with the corresponding parts. So I went from the endpoint with the double arc to the endpoint with the 90-degree angle. So I need to do the same thing here. Endpoint with the double arc to the endpoint with the 90-degree angle. So it's AB is congruent to DE. Then we have BC here is congruent to EF, and AC is congruent to DF. So those show that all the parts are congruent. Then I have my angles. Angle ABC is congruent to angle DEF because they're both 90 degrees. They both have the box. Then I have angle ACB, so the single arc, is congruent to DFE, single arc as well. And then I'll do my double arc. So BAC is congruent to EDF, and those are congruent. So now we've shown that all the sides and all the angles are congruent, so therefore the triangles are congruent. So we can now say that triangle ABC is congruent to triangle DEF. Now the question is, what if we don't have all that information? What if we don't know all the sides and all the angles? Can we still prove that two triangles are congruent? So in this case, we have no angles and all the sides. So we have three sides we know are congruent, but does that mean necessarily that the angles are congruent? So we know that AB is congruent to DE. We know that BC here is congruent to EF. And we know that AC is congruent to DF. And that's based on the markings here. So can we say that the triangles are congruent then? Well, in fact, we can. And it's by using this concept of SSS congruence or side-side-side congruence. And what side-side-side congruence says is that if we know that all the sides are congruent, then the triangles must also be congruent. So again, we can say that AB is congruent to DE. We could say that BC is congruent to EF, and AC is congruent to DF. Therefore, we know that the triangles must be congruent because all of the sides are congruent. So because of side, 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 we know that triangle ABC is congruent to triangle DEF. So what if we know that two sides are congruent and one angle is congruent? Well, in this case, we can see that we have AB is congruent to DE. We can see that BC is congruent to EF. And then we have this angle here, so we have angle ABC is congruent to angle DEF. Does that mean that the triangles are congruent? Well, in fact, it does. And it's by using this idea of side angle side or SAS congruence. So side angle side congruence says that if we know that two sides and the angle between them are congruent, then the triangles are congruent. Now notice here, I have a side, an angle, and a side. The order matters. If I had a side, this side, and I knew this angle, then this theorem would not work. The only way it works is if we have the two sides and the angle that goes between them. So here we know that AB is congruent to DE. And between them, we know that there's an angle here, angle ABC, that's congruent to angle DEF. And then we know that side BC is congruent to side EF. Therefore, we have two sides and an angle between them that are congruent, so therefore we can say that triangle ABC is congruent to triangle DEF. Now, what is a geometric proof? A geometric proof is a step-by-step explanation that uses definitions, properties, postulates, and previously learned theorems to draw a conclusion about a geometric statement. A geometric proof is typically done in a two-column proof, with one column being the statements and the other being the reasons. So what do geometric proofs look like? They look like this. So we have a column here that represents our statements. This is, what do we know? So these are the statements of, we know this, we know that, and so on. Now, the right side is the reasons, and that is the arguments for how we know that to be true. This is an example of a geometric proof. So it says AB is congruent to DE, and we have our reason as given. Given information is the information that they told us. So whether it's a marking or they state it in words, whatever it is, the given information is stuff that we didn't have to figure out on our own. It was told to us. Then we have AC is congruent to DE, given. Angle BAC is congruent to angle EDF, given. And then the triangles are congruent. Notice all of this was given information, but this part we had to come up with on our own, the SAS theorem, to prove that those triangles are congruent. So we use the theorems and postulates to fill in the rest of it. Let's take a look now at the SSS and SAS Congruence assignment. The assignment begins with the learning goals and success criteria. If we scroll down, there's a link here to take you to the Desmos activity. Go ahead and click on that link, and it should take you to a page that looks like this. We'll go ahead and click Start the Activity. The activity begins with the learning goals and success criteria. We'll go ahead and click Next. It says, which of the following theorems or postulates could be used to prove that the two triangles are congruent? So we need to decide whether this is an SSS theorem or SAS theorem. So you'll do that for each of these, and then we'll go ahead and click Next. Again, SSS or SAS. You'll answer that. Click Next. Now for this one, it says, given the triangles below, fill in the missing components in order to complete the proof. So we're given a partial proof here, and it says AB is congruent to what? Well, we can see that AB here is congruent to DE, so I'm going to go here and type in DE. And then we give the reason. How do we know that? Well, they have the symbols here. We didn't have to think about it, so that is what we consider given information. Then BC is congruent to, so BC is congruent to EF because they both have the double bars. So we'll go ahead and put that in, and that's given. And then here, AC is congruent to DEF. And how do we know that? Well, they gave us the symbols again, so that's given information as well. So there's my given information. And now I can say triangle ABC is congruent to triangle DEF. And how do we know that? Well, we know that all three sides are congruent, so we would say that is the SSS theorem. We can hit check it. It shows us what it should look like, and we can see that we did it correctly, so then we move on to the next one. And then for the next one, you'll do the same thing. You'll answer each of these parts, fill in the statements, and then fill in the reasons. And then when you're done with that activity, you'll go ahead and go back to your Google form and click Next. This will take you to your Before You Go. Go ahead and fill out your Before You Go, and then submit your work on Google Classroom.